Um, all right, we're being recorded. Hi, everyone. I really appreciate you taking the time to join my session today, and I appreciate this whole teacher section. It's really great hearing the different ways to use data from everyone. It's a lot of fun for me as well. I have a background in myself in outreach education, so I'm always excited to see new ways to get science out to people. But I will be sharing CrowdMag today, which is a free phone application. I've mentioned a couple times that go ahead and make sure you download the app before we get into the meat of this, because it'll make it a lot easier. But essentially, CrowdMag is a magnetometer sensor. It uses that magnetometer sensor already in your phone to measure magnetic fields in real time. And this data can actually serve NOAA research in geomagnetism. So you're going to learn how to use it for your own uses, but also how to contribute to NOAA research. I am a contractor with ICMS at NOAA's National Centers for Environmental Information, which hosts and provides public access to one of the most significant archives for environmental data on Earth. And if you have any questions, please feel free to put them in the chat. I loved how Elizabeth and Maria's section went with the links going out, but it'll just be me. I have the chat open, I can see it, but if I take a bit to get to you, don't worry, I'll get to it. And I will also be asking questions frequently. Feel free to put them in the chat, and if you're comfortable, you can unmute as well. All right, and go. There we go. All right, so the goals of this session is really three things. So we want to explain the very basics of geomagnetism so that the app makes a little more sense. I will say that I do have a PhD in geophysics, but I'm kind of the liaison for understanding these tools. If you have any really specific geomagnetism questions, at the end I have email that is our scientist team that really works on this application. Have at it. They love answering questions, so don't be afraid to. But I'll explain the basics. I'll explain them in common terms. And then I'm going to show you how to use the CrowdMag phone application in simple ways. There's lots of information within the app. If you've already downloaded it, you've probably seen that. It can be a little overwhelming, but that's okay. I'm going to help you learn the ropes, and then I'll show you how to actually use it within a classroom. And we'll have kind of two examples for that. We're actually going to do an indoor example, but the application really works best outdoors. So I'll explain how you can bring that outside and maybe for a field trip, walk around wherever, and we can explore that at the very end. So first off, if you haven't already, go ahead and download the application. If you have an Apple, whether that's an iPhone or a tablet, you're going to need to go into the App Store. If you have an Android product or tablet, you're going to need to go to Google Play, and the link for the Google Play is within I think the agenda. But you unfortunately cannot use this on the computer. And part of that reason is because the sensor that gives the ability for this app to work is within your phone and tablet. So pretty special that it's already there for you. If at the end of this you're overwhelmed, because I have a tendency when I'm excited about a presentation to really go in it and go quickly. I'm trying to slow down, but at the end, if you're overwhelmed, there's also a short tutorial on NOAA Education's website on how to use the application. And you can always reach out to me personally, and I'm happy to set up a time to go through specific parts of the application. Or if it's very technical, you can email that GeoMag team and all those emails and links and everything are at the very end of the presentation. So let's go ahead and get started. Oh, yeah, there we go. So if you have the application already, in order for the demo to work, you're going to need to turn on location services for the application specifically. That's because it uses your location to do the first part of using the world magnetic model. That'll mean something in a second, but in order to do that, I have the directions for how to do that on an Apple product. I, again, apologize. I do not have the Android directions because I'm not Android savvy. But if you have an Apple product, you'll want to go to your settings. You might have already gotten an alert if you went into the application that you'll need to do this. And you'll go down to the very bottom of settings where it says privacy, and I'll have that blue hand. You want to click that. pausing, so you can do that. Then at the very top of privacy, there's location services. You'll click that. And then once you click location services, this whole list will come up. These will be all your applications and the different applications, how they use your location. And do not worry if you do not want CrowdMag to use your location after this, that's totally fine, get rid of it, that's fine. But for using this in this demo, it will help. So you're gonna click CrowdMag where it says while using on mine, and CrowdMag has a little globe icon. And then you're going to change it to always. Just for this talk, not for always, always. So do not panic. So I'll give you a second to do that. If you have any problems with that, you will still be able to do this activity. It just might not work as well. So no worries on that. Okay, give them a second. All right, and this first section, I'm going to talk about geomagnetism. So if you're still trying to download the app or you're trying to set this, no worries. All right, so I told you I'm going to explain the basics of geomagnetism. And when I say basics, I really mean basics. So geomagnetism is a study of Earth's magnetic field. So the Earth works a bit like a bar magnet. The magnetic field is around us at all times, but is invisible to our eye like all magnetic fields, but it is around us. Other better known sources of magnetic fields include classic bar magnets and objects carrying electrical current. The three examples on the left are ways electrical current can make a magnetic field. Plainly stated, if you're on Earth or near any devices carrying electrical current, you have a magnetic field around you at this very moment. So that is all of us, even Bezos. Plenty of electrical equipment on that rocket he just went up in. So the magnetic field of Earth is generated by the movement of molten iron and nickel in Earth's fluid outer core. The effects of the magnetic field of Earth extends out to the magnetosphere, which protects the Earth from solar wind that would otherwise tear apart the Earth's protective ozone. So sorry, I always mess up this word, so I'm going to slow down. Magnetometers, there we go, magnetometers, which is what is in your phone or the tablet and what helps CrowdMag work, measure the magnetic fields near them. And CrowdMag helps you access this information that your phone already has, and it shows it to you in a map form, but also in a graph form, and we'll be looking at all those. So if you're getting a measurement from CrowdMag, this can be from the Earth's magnetic field, so that could be part of geomagnetism. It can also be things within the lithosphere or the crust of the Earth. It could be iron-rich rocks such as basalt, the magnetic field from those you could be measuring. Also, things like dramatic tides in the ocean that can create a magnetic field that affects readings, or large metal structures. So if you're standing next to a giant power line, that would also do it because it conducts electricity. If you're walking through New York, that would affect it as well. So there's a lot of things that affect magnetic readings, but all of them can help you learn about magnetic fields in general. And the application was really made for understanding geomagnetism, but it can help you understand all types of magnetism. So I have selected 2 science standards that I really think you could address with using CrowdMag. And there's plenty more, but the fact is that this app lets you collect real data about magnetic forces, and you can conduct a whole experiment around it. It gives you a tool where you don't have to go buy anything. I mean, you might need to have an iPad in the classroom and do it as a group. It depends on the setup, but it really is a tool in your pocket that can be used for real science. So hopefully everyone has downloaded the app at this point. Part of the reason we have CrowdMag too is to help inform something called the World Magnetic Model. Sorry, 1 second. This data that is collected through CrowdMag actually helps inform this international understanding of geomagnetism. this is actually a changing model too, because the magnetic field of Earth is from fluid materials in the Earth, so that does change with time. NCI and which is what I work for, and the British Geological Survey helped partner to update this world magnetic model. And they do it usually every 5 years, but in periods where there's a lot of change, they'll do it more frequently. And this model helps support navigation and is very important. So the data is really going towards something that's very important and that can help you inspire the kids. But looking at this most recent model from 2020, I want you to look, and this is the whole world, we're going to zoom in. I want you to look and try and figure out what you think the total intensity of the Earth's magnetic field will be where you live. So, and this is measured in nanoteslas, that's the unit. So I zoomed in on Earth. That is an assumption. I don't know if everyone's, sorry, Earth. United States, that's an assumption. I don't know if everyone's from the United States. But go ahead and take a moment and look at this. We have a key here. Each of those lines is 1,000 nanoteslas. So looking at this, if you could please put in the chat what you think the magnetic field intensity is in your location based on the model, which it's a model. So we have 48,000, 51,500, 51,000, 54,000, 49,000. Yeah, lots of variety. It's awesome. You can see people are really from everywhere. Awesome. Okay, if you found your own, write it down real quick because I'm going to come back to this. Make sure you write it down. Yeah, great. So you know how to use the magnetic model. Great. This is actually within CrowdMag as well, but I have the map. It's within the Google Drive that everyone has access to if you want to use this for any class material. But we're going to focus on where I put a little square is roughly Colorado. And the magnetic reading of that area should be around 50,000 nanoteslas. But we're going to see what it really looks like. So this is from CrowdMag. This is from lots of people collecting data, and it's in Colorado. So generally should be around 50,000 nanoteslas. What color, you can type this in the chat, do you think the icon should be based off the model? And there's a bar on the right-hand side for you to have an estimate. Orange, that's a little high. Yellow, yeah. Yellow to yellow-green, yeah. Yeah, exactly, yellow to yellow-green. Great, exactly. So obviously, there are yellow to yellow-green dots on there, but that's not what all of them are. That doesn't mean that CrowdMag collected erroneous data. It means a couple other things. So there can be anomalies because of a lot of the other things that give out a magnetic field. What do you guys think this blue line right here and this blue line out to the side? Any guesses what you think could have affected the data in that way where it's blue or just another color that consistently? Any guess? Cars. Good point. Roads, roadways, power lines, cables, yes, electric transmission. All of these are possible, quite frankly. So the power lines is a great point too. The biggest thing is that CrowdMag really works best if you're trying to get geomagnetism measurements, cell phone towers, that's good. It's really best to do it away from cars, out of your house, out in the open, because there's so many conflicting things. But even still, the lithosphere or the power lines underneath you can affect those readings too. My guess for especially with the pink line, this really bold pink line, is that someone did that recording in a car, which you're not really supposed to do, but hey, if you're trying to find measurement, that's fine. We just assume there's some assumptions when you're looking at the data that you can make from things like that. But yeah, it shows you the variety of magnetic field around in a location that the model is a great tool, but it is a tool that is looking at very specific things, and it isn't taking into account the local environment as much. That's why CrowdMag is so important, because it allows us to know more about the local environment. Okay, oops. Let me try and tap this. There we go. So I'm sorry, this is a little blurry. That is a bummer, but you should have the app already downloaded in your phone right now. So go into the app, open it up. It will probably pull up first a general map. I want you to click this icon at the bottom that has a little globe. That's the world magnetic model I was just talking about. So you have it in your phone, the model of what it should be. So go ahead and do that. Click there and you will come to this screen. Now, I don't expect all of you to know the latitude, longitude of your area, but thankfully you don't have to. Quick note, this number right underneath magnetic calculator, that is the actual measured magnetic field for where you are now. So that's not the model, that is what your phone is measuring. But we want to find out what the model says it should be. So click that target in the top right corner and it will fill in latitude and longitude and altitude for you. And then as you can see, this screenshot was taken a while ago, but you can go back to different dates. And like I said, the model changes. So it might be in a different model in a different year, but go ahead and do it for right now. And click calculate. I cannot speak today. Calculate when you're done. And once you do that, you will pull up, it's coming, here we go, this screen. So this screen is directly pulling from the world magnetic model to tell you what the model says it should be, which I circled in red, versus what is actually measured. So when this screenshot was taken, the model said that it should be around 52,000, but I was actually measuring 37,000. So you had on your generalization for what you thought your area should be, you now know the actual what the world magnetic model says it will be in your area. So go ahead and look at the difference of it. It's probably not a huge difference, but I'm going to ask you to do a little math. I know this is science focused, but I'm going to ask you to do it. I would like you to tell me the difference between what the world magnetic model is versus what you are measuring. Okay, so go ahead and type that into the chat. Oh, and if you could do negative if it's what you're measuring is lower, and I'll assume positive if it's not. So go ahead and put that in the chat. Lots of variation. We have everything from 450 lower to 10,000 lower. Let's see, 15,000 higher. Yeah. And it might be changing as you're sitting here too, because that can happen as well. 5,000 over. Exactly, Steve, because electronics, you're sitting in front of a computer right now. Yeah, and I don't know about you, I'm sitting in front of 3. So that has a huge effect. Yes, but if you were trying to find out geomagnetism right now, not a great time, right? But you're still learning about the magnetic forces around you by having your this device on. Great. Yeah, I love them. Keep coming with it. Let's see, 19,000 higher when I put my phone on my desk. Interesting. Interesting. All right, cool. So you might be making assumptions already about what types of things in your house will change the magnetic readings of CrowdMag, but don't get too excited. We're going to do an actual experiment for that, all as a group. The magnetic connectors in my rest keyboard probably have something to do with exactly. Yeah, anything magnetic near you can affect it too. Like I have a magnetic case on my iPad, so that definitely affects it as well. Very good. Thanks for the engagement, guys. I love it when people engage. All right, hold on. So I told you about this indoor experiment. You have your app, you're ready to go. I'm going to have you set something for the data in 1 second, but here's generally what we're going to do. It's you may notice you're far from a perfect scenario for collecting Earth's magnetic data without high levels of interference, but you have computers, electronics, like we're talking about. You might be in a large metal structure yourself, but you can still do magnetic readings, which they call magtivities within the app to learn about your surroundings. So before you do anything, I want you to plan out a walking route in your house. You can go outside if you're feeling real jazzy, but that will take about 5 minutes. So walk slow or sprint, I mean, if you really want to. But I'm going to give you 5 minutes to do this, but plan it out. Think of what you're going to walk by, things you're curious about, their magnetic field, and look around your space to do that. So do that in your brain a little bit, but then hypothesize what objects will disrupt the readings of your magnetometer and what you think will disrupt it the most. Thank you, I appreciate the warning. Then we'll come back and we'll explain how to replicate that same experiment outdoors, because that's something you could do with children as well, but indoor works just as well. So let's get started. Before we do our data recording, it will be best to set the polling rate to 3 seconds. So how you do that, click Settings on the bottom right-hand corner of the application. You're going to click the Magtivity polling rate. Right now it's set to 10. This would still collect enough data, but we really want to learn a lot. So we're going to change that to 3 seconds, since it's only going to be a 5-minute long recording. Feel free to change this at a later date, but for short recordings, it's best to do 3 seconds. I'll leave this up, give you a second to do that. Okay, if you've already done this and you're waiting for me, go ahead and look around, keep planning your route in your house. Make a little list of the items or areas that you think will disrupt your geomagnetism reading in general. Just think it through. Okay, moving forward. So I want you to click on the very bottom left toolbar of the app. There is an icon that says My Data. Click that. My Data is where you can record data, but is also where you can go back and look at old data. So right now you might not have any data, probably won't. So click My Data. Get ready, you're about to walk. Whenever you're ready, I want you to click record and do your walkabout. All right, don't do it quite yet. I will give you a heads up that in a normal scenario, if you're going on a walk, it would show you a straight line. Since you're probably indoors only within a block, maybe you have a giant house, I don't know, but it will just look like a lot of dots. Don't worry, it's working. Just record. So I'm going to start the timer. See, right. Well, it's kind of an awkward time. Let's do 5 minutes starting now. All right, go. Click record and walk around your house. I will sit here. If you have any dire emergencies or it's not working, I'm right here. Oh dear. And I also did realize the time, so we might have to cut it short, but keep walking, keep walking. I'll give you 2 minutes and I'll do it. Oh, no worries, Nick. The app is called CrowdMag. C-R-O-W, oh gosh, spelling out loud. CROWDMAG. And you can find it on Google Play or the App Store. It's free to download, so whenever you're able. All right. I hate to cut your experiment short, but let's give you 30 seconds more. So if you can hear me, if you're far away from the computer, 30 seconds more. All right. Ah, Gloria, I see you stepped ahead. Hold on, we're almost there. All right. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right. Come back or get close to where you can hear me. You're doing the next part. So it sounds like Gloria's there, but if you're done, go ahead and click pause. You won't have a long, pretty line like this. I'm sorry. You were inside your house. So go ahead and click pause. Then you will click stop. Then you will make a creative name for this test so that you can access this later, because once you save it, you have it in your record and you can always go back. Going slow in case people are still walking around having a lot of fun. I'm sorry. All right, so pause, stop, and then write a beautiful name. And then we're going to go to the screen that says graph. So at that bottom gray bar, you have pause or graph as options. Click graph. And it will get you something that might scare you a little bit. Don't worry. You'll get this. So before we dive into all of this, I'm just going to let you know that there's a lot of data here. I'm going to focus on the top part because that's the total magnetic field. The horizontal and vertical component, they're a little more in depth. And if you have questions about them, you can go over a little bit. Thank you. If you have questions about the vertical and horizontal, please reach out to me. I'll explain it the best I can. But for now, I want you to focus. See, how do you find the recording you saved? You should be able to hit my data. Sorry, let me look at the live app so I can tell you correctly. Oh, you hit Magtivity, Tamara. So in the top left corner, you hit Magtivity and you should have options. Like I've named a couple of mine test, a couple of mine afternoon walk, things like that. So click the one that you named. Thanks, good question. So we're going to focus on the very top chart. This is total field. And total field, it's the most useful for our purposes and probably for the classroom. Other ones, if you're doing a physics class, great. Use the other ones and I'll explain how you can apply that personally. But for this is what I came up with when I did a walk around the house. It wasn't today, I'm going to be honest, but I did it the other day. So normally I would suggest if you're doing an outside one and you're trying to really look at geomagnetism, I would say to click filter in that top right corner to remove noisy or unexpected data. But as it is, we want to see those. So what I want you to look at within your graph is my data said that, or the World Magnetic Model said that I should get recordings right around here for where I live. The majority of my graph is above that. I started at the computer, I walked into an open space, then I came by the kitchen, and then I was back at my computer again. So as you can see, it dipped when I was in that open space, and then it was higher when I was near electronics. So looking at your own graph, tell me one thing, tell me the highest recording you got on that top graph. So go ahead and do that now. I want to see how high we got it. Wow, big range there. You have some, is that 91,000? Wow. 65,000, 58,000, microwave at 69,000. Very interesting. Yeah. Ooh, we have 136,000. Got a lot of magnetic field around there. Very interesting. Yeah. So what objects, some of you are starting to answer this, what objects were giving you the highest reading? Can you tell by the map that you had charted for this? Go ahead and chat in what the highest readings came from. Do it quick because we got to keep moving. TV. Nice range. Power lines outside the house. Computer server room. That makes sense. Have magnets on the desk. TV. Electronics. Not positive where 91,000 was. Yeah, wow. PC. Bathroom. Yeah, lots of metal tubes. Printer. So very interesting. As you can see, this starts a lot of conversations you can have in the classroom of the magnetic field around of things in your area. And it's really fun to explore. I do this often, and it's fun to just see what's around you. And the graph is a great way to see it. So next, I'll explain an ideal scenario. Sorry to move ahead. There's some great things coming in the chat, but we got to move on. So ideal experiment, I'm going to go quick, but the ideal outdoor experiment is not in a car, not on a bicycle. You do the same thing we just did. You plan a route, you guess what will have the highest readings. And if you do that, then you don't want to stand too close to each other because obviously the phones will affect each other. But if you go in a group and you're about 2 to 3 feet away from each other, hopefully more, if it's COVID times, maybe we just do 6 feet and we stay that way because we're used to doing that. But you can do walk and export the data and then look at all the data next to each other, and you can really see what is an anomaly and what's a personal difference in your phone, maybe what's on you, a credit card in your pocket. If you have a magnetic case, that can affect it too. So if you want to export your data, you would go to settings in the bottom, click export my data, and you can send it to yourself in an Excel file by email. So this is an example of a whole group that went out and did this on that course. And there's some personal differences, like probably lady right here walked by something that no one else did. This is probably a large structure, maybe a bridge. So you can really learn a lot more about the magnetic field of objects around you this way. So real quick, all these links are, I'm going to upload the most recent version of this into the drive, but if you have technical questions, email the first email. If you have personal questions to me or about the presentation, my email is trinity.foreman@noaa.gov. We have lots of other educational resources at NCI's education page, so be sure to go there because we're trying to make more lesson plans. But I really appreciate everyone participating. And this is a list of people who really helped me and who gave me a little bit of science background to fill in the gaps. So thank you so much. Sorry I can't take questions, but just email me if you have them.
Trinity, you could take a couple of questions. We'll start.
I could? Okay.
About 3 minutes or so. She's good with it.
Thank you. I'm sorry I'm slow.
You're not. This is fascinating.
Any questions? Let's see. All right. There's some good questions. Okay, what is F, H, and Z? So F, H, and Z, F is for the full intensity reading. So that's the total intensity, like I was saying. Stick with that for now. H and Z have to do with horizontal or vertical elements of magnetism. Yeah, I don't want to go too deep into that because we'll be here for a while. And the resource list, Nick, I will re-upload my I added a couple links in it. I will add it to my Google Drive so you can hit all those links and get to the extra resources. Yeah, and thank you, Becky. Anything else that I can answer? Feel free to unmute too. A short explanation? Oh, that's a good question, Shelley. And I don't know. I'm gonna be really honest, I don't know. She asked if aluminum and other inert metals are read by CrowdMag. I don't know. Good experiment. Go do it. Also, the CrowdMag team would really know. So that's the first email within my extra, experiment. I love it. And the colors, yeah, that's a good question. The colors are just the intensity of magnetism. So yes, it's on that scale of intensity, it is different points. So if you're walking along a path, it's really a nice visual because you can see, oh, right here, when I cross this bridge, there was a really big spike. So when it's all in one place, doesn't really help, but for those long walks, it's really helpful. Okay, thank you. And sorry, I can't explain the different elements of it. Quite frankly, CrowdMag team can do a better job of it than I can. So if you really want to know about those extra elements, hit them up. They're ready for you. Thank you, guys.
Thank you so much.
Thank you, Trinity. So we are